Question. What do you think is the most consumed material on Earth? Now, the answer to this question might be seen as something of a source of pride for civil engineers, but it's one which has guided much of my research and one whose implications I'm looking forward to sharing with you for the next 2 minutes and 43 seconds. Turns out, second only to that universal solvent and biological lifeblood that is water, the most consumed material on Earth is concrete, and within concrete, Portland cement. Now, how much Portland cement does the Earth use every year? Oh, just over 4 billion tons. 4 billion tons. It's billion with a B. We consume more cement every year than we do staple crops for food, albeit not in the same way. And for the record, if you are, please consult your doctor. Now, this has one issue with it, and that is that cement production leads to the production of a lot of carbon dioxide. And those 4 billion tons of cement means 7 billion tons per year of CO2 emissions. That's steadily grown to account for 8% of all anthropogenic carbon dioxide. The industry solution for this are the use of a new material called pozzolans. These take advantage of secondary chemical reactions in concrete to reduce cement demand without sacrificing durability, sometimes even improving it. But these pozzolans are in short supply. They require other industrial processes, and they are very expensive. So how can we make concrete both cheaper and more sustainable? I would argue that the solution is somewhere beneath our feet. I've been studying the incorporation of local geomaterial from the South Island of New Zealand for use as natural pozzolan in Portland cement concrete. And here's how I do that in 3 easy steps. First, I've gathered rocks, dirts, and minerals from around the South Island, which I heat over 600 degrees to improve their reactivity. To make it sound more smarter, I call it calcination. Next, I use techniques such as X-ray diffraction, passing fine X-rays through tiny samples of powder to figure out what these cooked dirts are made of and how they behave in concrete. And finally, I've devised novel Portland cement concrete mixes, to which I apply a rigorous durability and strength testing regime to see how they behave under compression or tension. Now, the world isn't going to kick its concrete habit anytime soon, but that needn't come at the expense of the environmentalists' beautiful fresh world, nor at the developer's bottom line and budget. The work that I'm doing aims to prove that these materials, as pozzolans, are abundant, carbon-free, and at 1/10 of the cost of Portland cement, and they can be used to make concrete dirt cheap. Literally.